See? All right. Heyman, you seem really hung up on this gummy bear thing, man. Just chill, dude. It's only like the 4th day. You're here for 90. Relax. Man. Okay, so it said use a calculator, but if you didn't want to use a calculator, then again, it's not incredibly difficult because that is 25 over 1,000 negative, to the negative 2, which of course means you flip it to 1,000 over 25 to the positive 2. 1,000 divided by 25 is 40, negative 40 squared. Negative 40 times negative 40 is positive 1,600. And this one, 4 over 7 to the negative 3, negative exponent becomes 7/4 cubed, and then the exponent goes to everywhere inside, which is 7 cubed is 343 divided by 64. And that's how that one worked. Yes, of course, but anything from page 8?
Number
7. Simplify and then calculate. Well, I like to simplify first. So that is x to the 4th. Because when you multiply that in there, you add the exponents. And then you multiply it there. And what's 3 plus negative 3? 0. So that's plus x to the 0. And what is x to the 0? 1. So that is x to the 4th plus 1. Now, x equals 1/2. So that is 1/2 to the 4th plus 1, which is 1/16 plus 1, which is 1 and 1/16. Everybody Gouda? Excellent. Anything else from page 8? I know Ayaka said another number, but I don't remember it because I'm old. 10 BC? That was a long time ago. That too. But that was a real pain when the DC-AD changeover. Everyone's worried about daylight saving times, but back then, man, you didn't just set your watch. You had to get a whole new watch. Get it? BC-AD. Nothing. New watch. Time reversed. Counting down and started counting. I know, right? What are you going to do? Okay. 10 BC. So, 10, numbers with numbers. 5 times 10 is negative 50. Letters with letters. 8 times 3, you add the exponents, b to the 11th. And, oh, crap. I thought those were a and b. I didn't read that right. Simplify in here first. 5, 8 to the and negative 12 is b to the negative 4. And then negative 10, b to the negative 9. So that's negative 50. Negative 4 plus negative 9 is b to the negative 13th. That's not allowed, so it's negative 50 over b to the 13th. And c, same thing. Simplify there first. Negative 7, x to the negative 2. X to the negative 1, negative 7, x to the negative 3, negative 7 over x to the 3rd. The biggest mistake that you people will make on your first quizzes and such is you will be worried about that negative base, and you will not want to leave it as it is, because you will stick in your head, no negatives allowed, but it's only the exponents. Yeah? I'm out of water. Now I will get thirsty. That's all right. I'll be fine. Anything else from page 8? I just did 10b. Oh, 10d is in doornail. Got you. So, lots of ways to do this, but the way most of you are probably going to do it is distribute that 3 in there. So you have negative 2 to the negative 3, a to the negative 9, times 3 a to the 12th. Now, the negative 2 to the negative 3 isn't allowed. So you're going to have negative 2 to the positive 3. Negative 9 plus 12 is a to the 3. 3 times nothing is 3. Then all you got to do is deal with this. Negative 2 cubed is negative 8 over negative 8. Why is it negative 8? Because the negative is part of the brackets. So it is negative 2 times negative 2 times negative 2, which gets you negative 8. Anybody else from page 8? Loverly. Page 9, anything? 11D. Okay, so I would simplify that first. Then I would simplify that. Then I would stack them on top of each other. So this first yellow part is 5a3b squared times negative 2. Actually, I would do this one times 1 over negative 2 a to the negative 6. That's going to mess you guys up. I'm not going to do it that way. I don't want to do it that way. We're going to leave that a3b squared, and that's going to be negative 2 to the negative 3, a to the 6, and b to the negative 3. Now, in there, that's not allowed. So I'm going to make it 5. 3 plus 6 is a to the 9th. B squared plus b to the negative 3 is going to give me b to the negative 1, so it's going to go down there. And negative 2 to the negative 3 is going to go down there and become negative 8, just like it did before. Everybody's good? Now I'm going to simplify this one over here. That is going to be negative 5 to the negative 2, ba to the negative 16, and b to the 18th. So that is going to be the b to the 18th is cool over negative 5, negative 2. That's not allowed, so that's going to be negative 5 squared, which is 25, and a to the 16. Now, when I am dividing fractions, what must I do? Flip which? The right one. So I got 5a 9 over negative 8b times 25a. Make sure I did that right. Yep. Over, where was I? B to the 18th. Yep. And then we sort it out. It's 125 a to the 10th over negative 8 b to the 19th. Good? Anything else from 9? 11b. Same thing, except you got to be careful. This negative 3 only applies to the letters. It doesn't apply to the 10. So the 10 is staying there. P is going to become negative 9. Q is going to become negative 6. And R is going to just disappear. There's no R's up top because it's R to the 0, right? Over. Now this 8 does get affected. So it's 8 to the negative 2. P to the positive 6, Q to the negative 10, R to the negative 6. Now, a negative 2 down there means what? It's going to go up here. So I'm going to end up with 8 squared up top. 8 squared times 10. What's negative 9 minus 6? Negative 9 minus 6. Negative 15. So I've got P to the negative 15. What's negative 6 minus minus 10? q to the 4th. And what's r to the 0 minus minus 6? R to the 6th. What there isn't allowed? Only the p. 8 squared is 64. 64 times 10 is 640. Q4 R6 over P15. Again, I stress to you, there is more than one way to do it, but you have to apply all the exponent laws all the time. I am doing this in a much longer fashion than I would do for myself because I'm trying to show you every step that I am taking. Okay? If you can figure out how to get to here faster than me, go ahead and do that. Everybody understand? All right. Was I? Yeah. I went pretty fast. 125, A25, A19. Negative, negative. A25. I see that it says that. Oh, duh. Look at that. I forgot to bring that 16 up to there. See how easy it is to make a mistake? This was right for what I wrote, but I forgot to bring that 16 with me. All right. Now, good teachable moment, though. What would I do to you as a class if you handed this in to me? You put the 16 here. You flip the fraction like you're supposed to. You just forgot to bring that 16 up there. It's out of 3. What would I give you? 2.5. I might even be tempted to give you 3. Because what am I testing if I were to give you a test on this? Am I testing your ability to remember to Did you do all the math correct? You got all your stuff right. You got your 16 right. You remembered to flip the second fraction. And up here you did 9 plus 1. It's not even common sense. It's an error. It's not an error in math, is it? It's an error in copying it from one spot to another. Is everybody with me? Now, people can make the argument that, well, then everything is like that. No, not really. Because I can see quite plainly you got the important part somewhere in your work. Is everybody good? Okay. Everybody okay with the rest of 9? And 10? 14b. Okay. So that negative 2 applies to what? It applies to the 49? No. So since that's a negative, what's that going to do to this whole fraction? It's going to flip it. Is it going to change that exponent or the 5 and the 3? Just the 2. It doesn't change the 5 and the 3. So I write 49, and I'm just going to flip this. W negative 3 Z over 7W3 X negative 5 Z4. And all that is to what power now? 2. Positive 2. Right? Everyone agree? Mm-hmm. Okay. Now, let's deal with that 2. 49 W to the negative 6 Z squared over 49 W to the positive 6 X to the negative 10 Z to the 8th. Everyone agree? Everyone agree? The 49 will come in right there, correct? Yeah. Which means what's going to happen when I have 49 in the numerator and 49 in the denominator? They're gone. Negative 6 minus 6. No. Negative 6 minus 6. Negative 12. I've already got an x in the denominator and 2 minus 8. Z to the negative 6. What there isn't allowed? All of it. They're all negative, so everyone's moving, right? So I got x to the 10th over w to the 12th, z to the 6th. That's the green side. Now let's look at the yellow side. And I'll work that in red. What is everything to the 0? 1. So is any of this here important? No. So what's really in the numerator here?
1.
Well, what about that 14? So I got times 14 over x to the negative 8, z to the 8th. Yes? Now, I multiply 14x to the 10th over w12, x to the negative 8, z to the 6 and 8, 14. Now, what do I do? I got x and x, right? So what's 10 minus 8? 14x to the 18th over w12, z14. And again, there's way shorter ways of doing it, but it's whatever you need. Now, ladies and gentlemen, I could spend literally another week having you practice exponents, but I cannot. Right? We can't. There's a whole course to go. This is still grade 10 stuff, right? Nothing new here. Actually, when did you really start learning exponents? Grade 9, right? There's nothing new here. It's just practice. And we're almost done anyway. So did anybody want to talk about either of these last two multiple choices, last three? We're okay? Excellent. If everybody could flip to... where are we here? Page 12. Again, the concept is grade 10. We apply it more. We do more with the applications of it in grade 11. So, all of you should remember how to do this. This construction right here on your calculator, 9, and then the exponent button. You have to know what your exponent button is. Every calculator is different. Figure out what it is. You should know by the 11th grade what your exponent button is. I draw the little mountain because that's what mine is. Then bracket 1 divided by 2 or 0.5 if you can do it in your head. And the answer is, of course, 3. When you do it with 27, you get 3 again. When you do it with 625 and a quarter, you get 5. Because 9, the square root of 9 is 3, and 9 to the 1/2 is 3. So that tells you if square root of 9 is 3 and 9 to the 1/2 is 3, what do you know about the square root of 9 and 9 to the 1/2? They are both 3, which means they equal each other, right? Now, what is missing from these two blue spots in that square root symbol? Officially, what is missing? What should be right there above the root sign? A 2. What is every exponent that we don't actually write? 1. Notice, 1/2, 1, 2. We also know that the cubed root of 27 equals 3. And 9/27 to the 1/3 equals 3. And you should notice, there should be a 1 there. 1, 3, 1/3. Everybody remembers this, yes? Ayaki, you were not here when we were doing this last year. But logic should show you this, right? If that denominator as a rational exponent becomes the index, and that numerator becomes the exponent of the radicand, if that happens twice in math class, how often is it going to happen? Every single time. Because, although all of you will tell me math makes no sense to you, math is the only course that makes sense because it always makes sense, because it always does the same thing. Not like English, not like socials, not like even physics and chemistry change as we learn more and more stuff. Math doesn't. So this question here is not a problem. Without a calculator, what do you do with 0.04 to make it into something you can figure out without a calculator? You make it a fraction, 4 over 100. All that to the 3 halves. Now, what do you know about the denominator? Where does it need to go? Outside. So I'm looking for a square root. Now, when it was 9 to the 1/2, we had 9 under there. But now it's 4/100ths. So I put 4/100ths under there. And all of that is to what power? 3. What is the square root of 4? 2. What is the square root of 100? 10. And all of that is cubed. What is 2 cubed? 8. What is 10 cubed? 1,000. And I'm done. All of you should remember this. Obviously, you didn't remember it because you haven't thought about math in a year. But upon seeing it now, you should be like, oh yeah, I remember that. I've seen that before. Right? Does anything change with b? No. Where does the denominator go? Outside, it's the index. Where does the base go? It's the radicand. Where does the exponent go? Where does the numerator go? It's the exponent. What is the cubed root of 27? 3 to the 4th power, which is 3 times 3 times 3 times 3, which is, of course, 81. Now, I've added a new rule that you haven't thought about for a year. Does that mean we can forget all the old rules? No. So in this case, I have 2 exponents with the bracket between them. What do I do over that bracket? Multiply. What's 1/3 times 2? This finger represents 1/3. Multiply it by 2. 2/3. 8 to the 2/3. Now you have a single fraction. Where does the denominator go? Index. Where does the base go? Radicand. Where does the exponent? The numerator goes to the exponent. What is the cubed root of 8? 2 squared, which is 4. Everybody remembers, yes? What happens when it gets yucky? Why is this yucky? It's a decimal. Can we work with decimals in our heads? A lot of people have trouble with it, so I like to change it to a fraction. 49 over 100 to the 1/2. Where does the denominator go? Index. The base goes here, and it's all to the 1st power. Do I need the 1st power? No. What's the square root of 49? 7. What's the square root of 100? 10. Done. What's weird about E? It's a decimal exponent now. We haven't done anything with decimal exponents, except decimals are just fractions, aren't they? How do I make 1.5 a fraction? You could do 15 over 10, which what would you do if you were in grade 3 and were faced with that fraction? What would you do? You'd simplify it, right? And what is it? 3 halves. Now, can we deal with that? 16 to the 3 halves. What is it? Square root of 16 cubed. What is the square root of 16? 4 cubed. What's 4 cubed? 64. What are you going to do with that one? Do the same thing, because if it works once in math, it always works in math. That's 75 over 100, which is what really? 3/4. So now I have 81 to the 3/4. Fourth root of 81 cubed. Now, this allows me to remind you how to find these without a calculator. We're going to do a whole bunch of work reminding you of this, but it'll just take a second to show you this one because it's super easy. 81 is 9 times 9, right? 9 is 3 times 3. What's 9? 3 times 3. There's my group of 4, and I needed a group of 4. So what is the fourth root of 81? 3 cubed. What is 3 cubed? 27. So that is that. Now, why do I have to use a calculator for 8 for A and B? Zara. Of course you can, Zara. It's time. Why must I use a calculator for 8? Damaris. Fifth root of 8 squared. Does 8 have a fifth root? No. What's the biggest root 8 has? You've done it like 3 times in this. It's got a cube root, right? Cube root of 8 is 2. Doesn't have anything bigger than that. So these questions, sometimes you must use a calculator. In math class, I try to do as many of these as possible. But in reality, sometimes you got to use your calculator to get an approximate answer. So you do this the same way with your calculator that you did this. 8 exponent button bracket 2 divided by 5. And it's going to get you a crazy long decimal. In physics, chemistry, places like that, we're perfectly happy with the decimal. In math class, we would leave it as one of these. Everybody good? So what would this one be? Same thing. You're going to go 0.6, exponent button, bracket 15 divided by 7, bracket equals. And get another crazy decimal. Why would we do that? It depends on our final goal. If our goal is an answer, like we're doing an experiment in a physics class, then we actually do this. If we're in a math class, our goal is usually just to simplify, which is get it as pretty as possible without going to gigantic brackets or gigantic decimals. Because this, of course, is irrational, which means how long will that decimal actually go for? Forever and ever and ever. And we cannot write 20 bazillion decimal places, can we? Everybody good? All right. Turn your page over. Work these out with that formula. It'll take you about 2 seconds. It'll take a little longer. You figure that out, I'm going to get a glass of water. You add them. So I get x, what is 3 halves and 2 halves is x to the 5 halves. Is that a power or a radical? That's a power. How do I make that a radical? Where does the denominator go? Index. Where does the base go? Underneath. And where does the numerator go? Now, all of you should already see a pattern as soon as you see it once. What's that supposed to be? 2. What's that supposed to be? 2. Which means the indexes are similar. They're the same. And you'll notice, what did we do with our exponents? 2 plus 2 gave us our 5. Does everybody see? So, do these guys have the same index? Yes. So what does that mean? If they have the same index, the index is very closely related to the base, right? So if these two are the same index, then what do I get to do with those two exponents? Just by looking at it, without even thinking. I get to add them, right? So I'm going to have what for b? It's going to be the 4th root of x to the 5th, and it is going to be x to the 5/4. Is everybody good? Now, does that work for c? No. But does this long method we did work for c? Sure it does. What's this first one? X to the 3/2 times this one is x to the 2/5. Are they the same base? Yeah, one's x, the other's x. So what do I do with the exponents? Add them, which means we got to go back to grade 3 to remember how to add 3/2 plus 2/5. How do I do that? It's over 10 because I need a common denominator. And what is it? $15 plus 4 to get 19 over 10. So this is x to the 19 over 10, which is the 10th root of x to the 19th. Now I need you to notice something. Remember how I told you at the beginning of grade 10, if you were in my class, that you had 7 years to practice all the same math? Right? Well, here we are using what you were taught in grade 3 to do stuff that you learned in grade 11. All right? Every single thing you have ever done in math is needed to do pre-calc 11. You cannot let any part of it go. Now, the problem with this is sometimes it's something you haven't done a lot of since grade 5 or 6. But you still got to remember how to do it. Unfortunately, the way we have set up our math program in British Columbia, it thinks you're going to remember the stuff from grade 4 and 5, so it piles a whole bunch of crap into grade 11 without giving me any time to remind you how to do the old stuff. Is everybody with me? So I have no problem doing a bit of the old stuff, but the old stuff requires you to do a lot of practice early on, which is why I gave you all of these pages, right? I spent half a period reminding you how to do it, and then you got to practice it because you'd already done it. Everybody good? Okay, now, the rest of this you should be okay with. I just want to check something. Yeah, I better do a quick review of that too. Pay attention. You probably don't need to write this down, but I want to make sure. Using your calculator, tell me this answer. Using your calculator. garbage, right? Because this is irrational. So your calculator can't understand it, so it gives us a decimal. What do we know about that decimal? It will go on forever. If Derek's calculator screen stretched right out the window all the way to California, would it all fill up with numbers? Would it stretch all the way to the South Pole? Would it stretch all the way around the planet? Yes, because that answer of 6.9 blah, 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 blah will go on forever. Is that an exact answer? No. If we were in physics class, we would take that decimal, we would round it off to something, and we would say that's how far we went. Yes? Everyone agrees? We'd round it off to, what is it, 6.92, what is it? 928? So we'd say we went 6.928 meters or whatever. Even though we went a little bit further. Everybody gets that, right? In math, we don't like those decimals. We don't like them because they go on forever. They're not exact. So you all remember in grade 10 that if someone asks you for an exact answer, it's this simplified. And you simplify that by breaking it down. That is 16 times 3. Everybody agree? 16 times 3 is 48. What is the square root of 16? 4. So we bring a 4 out and we leave the 3 under there. Does everybody remember that? This is what we do in math class. That's what I'm looking for. Do people need to be reminded of how to do that a little bit? Do you want to see a couple more? Or are people cool with that? Everyone remembers that from grade 10? I don't mind doing another one. 72. That is the square root of 36 times 2, right? What's the square root of 36? So what comes out? 6. What stays under there? 2. So that is what we call an exact answer. Remember, if your calculator gives you decimals, that's an irrational and it's an approximate answer. Everybody good? Now, if you look in your assignment for today, what am I asking for? Exact values. So don't just punch 27 exponent bracket 2 divided by 3 into your calculator. That's physics class. That's not math class. Everybody good? Now, let's get back to where we were. I am not going to do all these for you, but I am going to point out some things that will help you. What do you notice about 0.3 and 0.3? Same base. So do we know what to deal with? Even though it's a decimal and we don't like it, it's the same as having x and x, right? So what are we going to do with the exponents? If it was x and x, we'd add them. So we're just going to add them there, even though it looks freaky. Look at this one. It looks scary. But if I wrote this, x to the negative 4 squared, what would that give me? What would I do with those two exponents? Multiply them. So it would be x to the negative 8, wouldn't it? But it's not an x, it's negative 3/2. So you know what to do, right? 3, no problem, same base. What about 4? Is it all the same base? So all we're doing is adding and subtracting, right? They're fractions though, so I got to remember how to add and subtract fractions. Everyone is good? 14, page 14, nothing freaky there. Really until number 10. Most of you should be good with that. So it is 12:37. I would like you to have up to the end of 15 done in class. the end of page 15 done in class. Now, when you look at a lot of this, you should be able to recognize that a lot of it you can really do in your head, can't you? Right? So you guys work on that, and then I'll make